G'day everybody, Nick Dingle here for lesson number 10. We're going to be looking at functions and parameters when it comes to Python, what they are, how to use them, and how good they actually are. Now, to give you a bit of an introduction about what the hell a function is a block of code similar to like when we did if statements that you can name and you can call on multiple times. So essentially think of it as, like up here, I've got a function I've called say hello with 2 lines of code inside the scope of that function. That's why they're indented. And now these lines of code can be used just by typing in say hello. And I can do that multiple times. Now, why would you do something like this? Well, for starters, if you're finding yourself copying and pasting huge chunks and swathes of code, functions are amazing because you write them once and you use them as many times as you like. It's wonderful for that. The second thing is it allows debugging, because if most of your code is broken into really understandable chunks of code and you know that function 1 here does adding, function 2 does subtracting, and that's a bug in your adding code, you know where to find it. It's up in the adding function, that kind of stuff. The third thing is it makes it easier to read. Not only is it a little bit neater, you can actually collapse it, just like I showed you with an if statement, to hide that finished code. And finally, it can be used almost anywhere within a script. So let's have a go at doing this example right here, just going through how you do it. So to create a function, you first define it with the def keyword, short for define. You give it a name, something like say hello. I like to use capitals at the beginning of my function names just to distinguish them from variables, because I like to use lowercase for variables, uppercase for functions. Not everybody does that, but I do personally. Okay, let's get their name. What's your name? Like so. And then let's print an F string, hello name, like so. Now, let's put a quick print and then hello. I'll put a lowercase there so you can tell the difference between those. So what I want to quickly demonstrate without calling say hello is what happens. So let's press play at the top, and you may notice all we get is the lowercase hello. We don't get the what's your name, and we don't get the hello name. All right. It's basically been skipped over, a little bit like an if statement block. But what's happening there is when you define a function, the code inside doesn't actually execute straight away. It only executes when you call it by its name, and its name is say hello. So effectively, the first line in our script is no longer this line 1 here. Technically, it's line 4 because this is the first line of code that's not inside the function. So this line will execute, then this line, and so forth and so forth. And if we call on the function, such as here, it will actually execute that line first, then say hello, which will make it jump up to line 2, then line 3, and when that's finished, it comes back down to where it was called and continues if there's more lines of code underneath that. So let's hit play, make sure it works. It says hello, what's your name? Let's do the horrible dogman again, and it says hello dogman. Simple as that. Okay, now I'm going to put a breakpoint on here. So just like in our debugging video, I'm going to do a line-by-line stepping just to show you what it's like when you're running a function. So if I press F5, we're going to run in debug mode. We get our lovely windows over the side here, and we're frozen on line 6. So right now, this line of code has not executed. And I'm going to use the stepping tools up here, specifically the step into, because step over means it's going to do the code inside the function, but it won't show you. Step into will go into the function and run one line at a time. And step out is when you're in a function and you're sort of over it and you want to get out of the function so you can step by step back where it called from. So let's do the step into, and you can see it jumps in. One thing to note there is we now have a call stack. So a call stack is, all right, what functions have been executed and in what order? So module is literally like the main body of your code. Then say hello was called next. And if you call another function, it will actually put it on top of your stack. Okay, and it will just keep adding on top. All right, so let's press F11 or press this one. What's your name? Dingle. All right, goes to the next line. It says hello Dingle, and you'll notice it jumps instantly back into the main function. And if I press F11 one more time, it shuts down. Very nice. Okay. So that's the behavior of a function. And the really cool thing is because I've named this code block, I can just write its name multiple times. And when I press play, it works multiple times. And it's going to just keep going and going so long as I keep calling it. All right. So that's a very simple example for something a little bit more complex. Now I'm going to introduce something that I haven't actually talked about yet, and that is modules. Modules are chunks of code someone else has written, and this one right here allows us to color in text. It's called Colorama. If you want to learn more about it, Google Python Colorama. But if you want to install it and use it and follow this little chunk of code, come back to Visual Studio and let's install it very, very quickly. So I'm going to press F1 on my keyboard to bring up this list of items here. So F1 at the top. Click on Python Create Terminal. And down here, I'm going to type py-m pip install Colorama. Press enter. And it tells me I've already got it installed. That's perfectly fine. If that didn't work for you, try pip install Colorama. If that doesn't work, try python-m pip install Colorama. If that doesn't work, I'm scared and I don't know what's happened. Okay. So let's try out the Colorama example. I'm going to comment this code out and we're going to bring in the Colorama code by typing from Colorama import 4. Now 4 is just foreground colors. That's all that is. Let's set up our new function, colorful hello, like so. And the way you use colors is you simply print the color that you want to color in, then the text after it. Never the other way around. So let's print and let's go 4.red plus, so we're going to use the concatenate symbol there, hello with a space, get rid of the end line so it doesn't go to the next line, print for green, just so we're a little bit festive because it's Christmas. And on the next line, I'm going to print 4.reset. And that simply goes back to the original console color. All right, let's use it. Let's type in colorful hello with some brackets because you need brackets on function names. Press play and it gives us hello world in some colorful sort of stylings there. And again, I can print that as many times as I like. There we go. Don't know why it didn't work that time, but it worked the second time. All right, so there's a slightly more complex function. I've just introduced modules really, really quickly, so I suggest go and learn about those because there's some amazing ones out there. I will spend a video talking about them, but not today. All right, rules. There are rules that apply to the names and some things about functions that everybody needs to know. It's a little bit like variables. You must follow some rules and there's some suggestions otherwise. So firstly, when you name a function just like a variable, you can only use numbers, letters, and underscores. Okay, you cannot use special symbol spaces, percentages, things like that. You'll get errors. Second thing is it must start with a letter or an underscore, just like with variables, you can't start with a number. And finally, with functions, the function must appear above the code that is trying to call it. Okay, so for example, let's go back to my colorful hello. If I define my function underneath where I'm trying to call it, you'll notice that we get an error and it crashes saying it's not defined. It simply needs to be defined before you use it. Okay, that's the only way that I can sort of explain that. It needs to be above before you use it. All right, and the last thing is, this is more of a sort of a guideline. Try and keep your functions to a single purpose, okay? One logical thing. Do not make a function and then put 500 lines of code inside that function. Realistically, you should be able to have just one function doing one thing, keeping it to maybe 20, 30 lines of code if you can help it, okay? So those are my rules. The other rule that I sort of go by is, I mentioned it before, uppercase letters for my functions so I can distinguish them from variables, which I use lowercase letters for. All right, more examples. Organizing your code with functions can be incredibly handy, okay? I'm just going to quickly point to this example. We're not going to type it out or anything like that, but you can see I've defined 3 functions at the top, and I have used the pass command so I can set them as incomplete functions, okay? They exist, they just don't have any behavior to them. Pass just means I'm done. A little bit like with the if statements. Now I've made 3 of them, rectangle, triangle, and circle. And down here in our main body of code, you can see I'm printing a menu, getting the input from the user, checking what they chose, and then calling the associated function. So this is a good way of trying to break up your code into logical chunks. So let's say, for example, this is like an area calculator or something like that, or it draws the shape on the screen. If I choose A, all the code to do with the rectangle should exist up here inside the rectangle function. And the same thing for triangle and the same thing for circle. So you can see how that just organizes your code a little bit, makes it logical. The other thing that it does do, and I'll show you back in Visual Studio, is when you click inside a function, you can sort of see you get a breadcrumb menu at the top here. It tells you where you are roughly within your body of code. And this tells me I'm in this script inside that function. And if I click out down here, it doesn't have that breadcrumb anymore because I'm in the main body of the code. Okay, so that's just one quick thing to note. And the last thing, just to give you a bit of a term here, an incomplete function is also known as a stub. Okay, think of it like a ticket. When you go into the movies, they tear the ticket in half and you're left with a useless little piece of paper known as a stub. That's what this is here. It's a stub. It's a bit useless, but it's essentially a way of a programmer testing their code and getting something there before they implement the hard bits. Okay, so with that said and done, let's jump into some deeper concepts when it comes to functions and code. A parameter. A parameter is essentially you making a variable that you can pass a value to in your function, and it can change the behavior of your function. So for example, just over here, I've made the say hello function again, but this time in the brackets, I've included a variable called name. And you might notice I got rid of the input line and I've just said print hello name. So let's go and have a look at this. Let's jump in once again, comment all this out, and let's go define say hello. And in the brackets, I'm going to put name like so. Print hello name. Whoop, forgot the F. Beautiful. So say hello now has one parameter called name, and I can pass that parameter a value. Now, values can come from literal, so you can just type it in. You can also pass it from other variables, okay? They can also come from the user's input. It's entirely up to you. So the way we use this is I simply type in say hello, and when I open the brackets, you'll notice now it's asking for a name. So let's put Dingle in the brackets. Press play, and it says hello Dingle. Simple as that. Breakpoint time. Bonk. Okay, if I press F11, you'll notice that up here, we're in the say hello function. It's already made a variable called name, and it's been set to Dingle. So when I put that in the brackets, it's literally saying name equals Dingle, just like that. And when I use the hello and then F string of name, it's printing that value on the screen. So if I want to print hello for different names, like so, just quickly get rid of all those, then it's reusing the same function, but it's changing the functionality ever so slightly. And to give you a bit more of an example of this, okay, let's introduce that Colorama again and have it so we can choose what color the hello comes up as, okay? So let's put this line back at the top. This might be a little bit fast, but please try and bear with me. Okay, I'm going to have a second parameter. So the way to add more parameters is simply by putting a comma and then putting another variable name. So I'm going to put color. Now, American spelling might run into some problems. That's why I like to use the Australian spelling, because I'm Australian. But for this, I say color, like so. And then we print the color. Oh, I probably could do it down here, couldn't I? I'm being a bit silly about this. I print the color first, then the word hello, and then the name. And the way I can do this is straight after Dingle, To specify what color I want to use, I'll put a comma and I'll put 4.red, just like I did before inside the color for hello. So let's try the same thing for Alice, but this time cyan, and the same thing for Emily, but yellow. Why not? So what I'm doing now is passing two parameters. I'm passing the name value to the first one, and then the 4 red into the color value, the second one. So when you specify values, you're specifying them in order. Okay, press play. And there we go. Now I didn't do the reset. That's why the bottom is still yellow like Hello Emily is. So can you see how parameters allow you to change the behavior of functions? It's incredibly handy. All right. One last thing that I want to do here is demonstrate to you. If I have two parameters inside my function definition and I only try to pass one value, I am going to run into an error. Because right now it's saying missing required argument color. Argument really is just a interchangeable word for parameter. Okay, so missing value for parameter color. So if you have two parameters, then you must have two values when you call that function. Now, there is one way around this though. You can set what's called default values to parameters. So let's say, for example, my default color, I want to be blue. Then all I need to do is type in the parameter name and make it equal a value. And if I do that, now when I call this one with just a single value for name, it actually knows what it's talking about and it will make sure that that one is in blue because I didn't specify a value, but its default value is blue. So this is parameters, and parameters can be numbers, they can be strings, they can be booleans, whatever you want them to be. They can be lists, which we will once again talk about in the future. Okay. And here's another quick example for using multiple parameters. So I've set up an add function here with two parameters, num1 and 2, and I add them together and I print the answer on the screen. I'm going to quickly redo this. I'll pause the video and write it up. Okay, so I'm back. I've written up the code exactly the same way that it was in the slideshow. So we're going to have a new function called add with two parameters, num1 and num2. It adds those together, stores it in answer, prints that answer, and then it goes back down. So if I run this, I'll get two values of 4 and 12 because it's added up my two values and then print it to the screen. Okay, so that's all well and good. Another example using multiple parameters. However, let's take this once again to its final conclusion for this video, this idea of a return value. So let's say, for example, I have an add function. What if I don't want to print it to the screen? What if I actually want to use that add in another equation? I actually want to add three numbers together and I don't want to print them until I'm done using the third number. Now, realistically, I could add a third parameter, but that breaks what I'm trying to explain here. So let's ignore the third parameter for the moment. Well, what we can utilize is a thing called a return value. It's essentially like passing back a response to whoever called it. So for example, down here is my first call. It'll do my maths, and then I can return the answer, and then we can do whatever we want with that. Okay, we can store it in a variable. We can print it to the screen. We can use it in another function. All sorts of things, okay? In fact, you know what I might do? Just had an idea. Let's set up a function called subtract, and let's do the exact same thing we did before. Okay, and print answer. Subtract, and we'll swap those around. Oh no, well, I might do num1, num2. Bear with me. Okay, cool. So there's our add function result, and there's our subtract function result. Now, I don't want to print to the screen. I want to take the add result and I want to use it in my subtract function. Now, that's really convoluted, I know. However, this is the best way that I can explain it. So let's get rid of this print. I don't want it anymore. We're going to turn it into a return, like so. And what that does is it returns the value down here, and you can treat it like a variable. So like, for example, I can say add answer equals, and what it does is it sends 1 and 3 up. We calculate the answer. 4 is returned, so 4 goes into add answer and it remembers the number 4. Okay, and then what can you do with it? Well, for this example, let's just print it to the screen. I'll get back to subtract in a second. Okay, you can still see it says 4. It's doing the same thing, but we're now using the return, so it's a bit more flexible. So let's use add answer inside our subtract function, and we'll print this one to the screen though. So you can use your function in a print. That's perfectly fine. So 3, none. Okay, and the reason why that's happening is because silly me forgot to turn that into a return. There you go. Now it just says 3. So if you think about it, 1 plus 3 is 4. 7 take away 4 is 3. Okay. So this is the return value. These are parameters. These are functions. If the parameters and the returns are a bit overwhelming to begin with, I suggest just stick with functions for quite some time. And when you get used to it, start introducing some parameters, really basic ones. And then once you've got that down pat, try and get the return values working. You're going to see the benefit as you go along. So thanks for watching, guys. I'm going to catch you in the next one.